Alright guys, time for differential equations day 3. Alright, so just more of the same. We're going to be separating and solving, plugging in some initial conditions, getting equations for y. Alright, so for first problem, looks like we need to do some factoring if we're going to separate out the x's and y's. So we have a common factor of 4x cubed, and that'll leave us with just y plus 3 left there. Alright, so we should be able to divide by our y plus 3 and multiply by our dx. So we'll end up with 1 over y plus 3 dy is equal to 4x cubed dx. Alright, this one's pretty similar to ones that we saw in our day 2 lesson. So if you want to pause the video now and try to finish it out from here, that would probably be a good idea. Then unpause it and see how you did. Alright, so this is a y to the first power in the denominator, so we are going to need to use a natural log to integrate that. I need to put my integral symbols here. Alright, and we'll have the natural log of absolute value of y plus 3. Over here, we're just doing the power rule, 4x to the fourth divided by 4. The 4's will cancel, so you get x to the fourth plus c. Alright, I like to plug in my initial condition right now, so we're going to plug in -5 here, and we'll end up with the natural log of 2, because that would be -2, and the absolute value turns it into positive 2. And then 1 to the fourth is just 1, and we'll subtract that 1 over. So c is equal to the natural log of 2 minus 1. Alright, so let's rewrite our function over here. So we have natural log, absolute value of y plus 3, is equal to x to the fourth plus natural log of 2 minus 1. Alright, so now we need to exponentiate both sides. So e to the power of this log and e to the power of everything else over here. These will cancel, leaving us with the absolute value of y plus 3. And then these we're going to separate into 3 separate exponential functions. So e to the x to the fourth times e to the natural log of 2 times e to the -1. Okay, and so we know that e to the natural log of 2, the e and the log cancel, so we're going to get that 2 in front. And then these two e's we're going to go ahead and combine back together. E to the x to the fourth minus 1. Okay, we can also drop our absolute value bars, but when we do that, we have to remember that that creates a plus or minus, and we need to make the decision of which one it is. Alright, and so that decision is made for us actually by the initial condition. Our initial condition is a negative number. The only way an exponential function can result in a negative number is if there was a negative in front. So it's going to be -2e. Alright, and last step would be to subtract that 3 over. So y equals -2 e to the x to the fourth minus 1 minus 3. Alright, so this next one you can for sure do on your own. Alright, you've seen plenty of these examples now, so definitely pause the video right here, try this one on your own, try to get it all the way. It does mention something about stating its domain at the end, so if you want to skip that part and just watch the video there, but all the solving part you should be able to do on your own pretty easily. Alright, so separating this out, we're going to multiply y over here, so we get y dy, and we're going to multiply our dx over here, and we get 4x dx. Alright, then we're going to integrate both sides. So this side we end up with y squared over 2. And over here we get 4x squared over 2. And the 4 over 2 reduces to 2x squared plus c. Alright, going to plug in my initial condition right now. So that -2 is going to become a 4 divided by 2 is 2. Plugging in -2 here, we get a 4 times 2 is 8. And so -6 is what c is equal to. Alright, so we'll rewrite our function over here. Y squared over 2 is equal to 2x squared minus 6. Alright, now we need to get our y by itself. So we multiply by 2. Y squared is equal to 4x squared minus 12. And then we square root y equals the square root of 4x squared minus 12. And just like with our absolute value on the last problem, since we square rooted both sides, we have that plus or minus situation here. So we need to make a decision, is it a plus or a minus? All right, remember the only way a square root can result in a negative number is if you have a negative in front of that square root. All right, so that is our answer here. Now they did say this extra part of state its domain. All right, so sometimes you're asked to say what the domain of the function you've gotten is. All right, and this does not have a domain of all real numbers. Remember, we cannot get any negative numbers inside our square root. So we're going to pull that part out, 4x squared minus 12, and we're going to set it equal to 0, and we're going to get some critical points here. So we're going to add that over. 4x squared equals 12, x squared equals 3. So x equals plus or minus the square root of 3. All right, these are our critical points. We just need to make sure that our inside part's never negative. So the easiest way to do this is to create a little number line here, just like we do with derivative testing. All right, we're going to pick a point in each region, and we're going to plug it into what's on the inside and make sure that it's a positive number. If it's not positive, we want to leave that part out. All right, so left of square root of 3 might be like negative 2. Then 0 in the middle, and then like positive 2 on the right side. So if I plug in negative 2 and I square it, I get 4. 4 times 4 is 16 minus 12. That's a positive number. That's good. That's what we want. If I plug in 0, I end up with negative 12 on the inside. That's a negative number. That's bad. Plug in positive 2, and we end up with that 16 minus 12 again, back to positive. So our domain of this function is actually x is less than or equal to the negative square root of 3, or x is greater than or equal to the positive square root of 3. All right, we could also have gone with interval notation there, negative infinity to negative square root of 3 included, unioned with the square root of 3 to positive infinity. So either one of those would be fine. All right, last one we have here is just kind of beefing up our application problem. We saw a little one in our last lesson, so now we're going to do a little more with it this time. I'm not going to read through the whole question. You can pause the video, read through it for yourself. Just going to point out a couple important things. Obviously, the differential equation over here, that's going to be important. Our initial condition, we're most likely going to be using that at some point as well. All right, so part A asks us to find d2n over dt squared, the second derivative. So the differential equation they gave us is the first derivative. Now we need to find the second derivative in terms of n. All right, so our answer has to be in terms of n. All right, so we start by, let's take the second derivative. So d2n over dt squared. So I'm just taking the derivative of this equation over here. All right, so the 1/3 constant we can just pull out to the front, and then we're multiplying that by the derivative of 750 is 0, and the derivative of negative n is negative 1, times dn over dt. So we have to do the chain rule, and so that's the chain rule part. We're doing an implicit differentiation here. All right, so this is, if we simplify, it's just negative 1/3 dn over dt. But the problem with this answer is that it is not in terms of n, like they asked for. It's in terms of dn over dt. So we need to make a substitution. We know what dn over dt is. It is equal to the 1/3 times 750 minus n. And if we just simply plug that in, we get negative 1/3 times 1/3 times 750 minus n. All right, and just do a little simplifying here, and we have our answer for part A, which would be negative 1/9 times 750 minus n. Now we have our second derivative in terms of n. All right, and there's a second part to this question, so we actually have to use the second derivative to determine whether the graph of n is concave up or concave down when there are 250 wolves in the forest. All right, so 250 wolves, that's our n, and we just need to plug that in to our second derivative here. So that would be d2n over dt squared, evaluated when n equals 250. All right, so it's negative 1/9 times 750 minus 250. All right, we don't really need to know what this number is. We just need to know if it's positive or negative, because the second derivative sign test tells us whether we're concave up or concave down. All right, so 750 minus 250 is a positive number. Multiplied by a negative number means this is less than 0. If the second derivative is less than 0, then the graph of n is concave down. So n is concave down at n equals 250. All right, part B is going to ask us to separate and solve. So we want to find y equals n of t, particular solution with our initial condition. All right, so we're just going to write down our function here, dn over dt equals 1/3 times 750 minus n. All right, so we're going to divide by our 750 minus n, and we're going to multiply by our dt. So 1 over 750 minus n, dn, is equal to 1/3 dt. Okay, we're going to integrate this. So we have an n to the first power. That's a natural log. Absolute value of 750 minus n. And then don't forget your chain rule here. Really, it's a u substitution. We saw this in our last free response question. Anytime your variable is negative, you're going to end up with an extra negative constant. So it's actually negative natural log of that. Over here, just integrating the constant 1/3, so we just tack the variable on. Don't forget your constant of integration there. All right, let's go ahead and plug in that initial condition right here. So 0 for t, 150 for n. So we end up with negative natural log of 600 is equal to c. All right, so let's rewrite our function over here. So negative natural log, absolute value of 750 minus n is equal to t over 3 minus natural log of 600. Okay, we need to get rid of our negative sign in front here before we can get rid of the log. So multiply everything by -1. Let's just switch these around. Natural log of 600 minus t over 3. Now we can do the exponential function. Make sure both of these things get that. So we get the absolute value of 750 minus n is equal to e to the ln cancels, so we just get 600, and then e to the negative t over 3. Okay, we can drop our absolute value bars now. And remember that creates a plus or minus, so we need to make sure we determine which one it is, and our initial condition is a positive number, so it's going to be the positive 600, not the negative 600. And so last thing to do would be to get n by itself, so I like to think of it as we're adding n to this side and subtracting 600e to this side. So n equals 750 minus 600 e to the negative t over 3. All right, make sure we answered all the parts, and we did. So that'll be it for day 3. Hopefully you enjoyed, and I will see you next time.